What's up, fellas? Oh, it's been a minute. It's July 11th, Saturday afternoon. Oh, about 7 o'clock. Just hanging out in the shop a little bit. Got the TV on, watching the World Outlaws from a couple days ago. Hometown hero Dalton Wilson won his first Lucas Oil super late model race. Pretty cool. He's from up in the Fayetteville area, and he was, like I said, a hometown hero right around Fayetteville, and we've raced with him before. Young guy, really good driver. Just got that on the TV. Messing around tonight on a set of iron heads for a customer. I'm just going to go over this a little bit. I see a lot of people always say, oh, you mess with these old iron heads, throw them out and buy some new heads for what you're going to have in them. And they're right. I mean, to do the modifications that are needed on a set of 50, 60-year-old small block Chevy heads, the bill adds up for the amount of machining operations you're going to do. But depending on the car, I mean, there are some classes that still have to run iron heads. This isn't one of them. This customer is building a traditional street rod, like a 32 coupe, like an American Graffiti kind of deal, and he wanted something nostalgic. He didn't want to put a late model aluminum head on there. And, the new iron heads, there's not much to choose from anymore. Since Dart shut down, it's hard to get cast iron castings that are worth a damn. A few aftermarket foundries are making the Vortec heads, but again, this guy didn't want a Vortec, a late model head. This car's got a little stroker motor small block, and he wants to run on pump gas, so his choices are limited. The particular head we're using here is a run-of-the-mill old Chevy 441 head. Now, your 441 head was an open chamber design, and the reason we're using that is because he wants to run on pump gas, and he's 380 some odd inches, so flat top piston motor to be friendly on pump piss. We got to get the compression down a tick below 10 to 1 to be nice and sedate on the street and not burn up a bunch of parts riding around, and still have a little bit of timing in it where it can make some power. So we started out with an old crusty set of castings that came in. So far I've already worked on a little bit, and I'll catch you up to speed. We hot tanked them, old school, we have an acid dip tank that we still use. And a lot of people don't know, years ago people would bring in stuff and we'd hot tank a set of heads for 25 bucks. Now the chemicals super expensive. The caustic chemical is right at $300 for 25 pounds worth. And years ago, I could mix up a batch in the hot tank, clean it out, and put a new batch of caustic acid, and it would last close to a year. Now I'm lucky if it lasts 3 months, 2-3 months, depending on the duration I'm using it. And it's tough. $300 in chemical. And then the old chemical, we removed it. I have to pay to have it hauled off because you just can't dump it out by the train tracks or in the ground. So, we start off tearing down a set of heads and acid hot tanking heads. We charge $100. So that's, already we're starting at $100. And that comes with the, I'll go ahead and Magnaflux or pressure check the heads. So $100 alone just to clean and mag them. So after we did that and the heads checked out okay, that's the other head on the ground there. And the acid, when it's nice and clean, it does fairly well. It just sat in there. I let them sit in there for about 6 hours. Still let them have a little bit of soak time. But still, it runs the electric bill up. Our little backyard machine shop, our electric bill still runs over $1,000 a month back here. And that thing's nothing but electric heating element. Not as efficient as a gas-fired hot tank, but that's what we got. So after we cleaned them and pressure tested them, I got them up here on the seat and guide machine. My trusty old DNC 20. And I just machined them for screw and studs. We pulled out the old, if you remember the old small block, every small block came with press-in studs. So they're prone to have problems when you put a high lift cam or any kind of valve spring pressure. Anything more than stock, you're going to have a problem. The spring pressure alone will actually extract the stud out of the head. So we have to remove those. We have a little fixture that we pull those out with. And after we pull those out, we machine the bosses down. Now I machine these down with a little end mill tool. It's not even an end mill, it's like a counter bore. And it lines up in the pilot hole of where the press stud comes out. And then we just put it here in the chuck. And just mill it right down. So you mill this down, as you can see I already did this, but you mill it down the thickness of what your guide plate and the hex on your screw-in stud is. And I'll show you that in a minute. I don't have one around here. But it's usually right about 3/8 of an inch. So we plunge that in with our little counter bore, 3/8 of an inch. I set my stop on the quill. Just come on down and plunge. Take off 3/8 of an inch, go down the line. And then I go back with a countersink. And I put a nice countersink to start in for my thread. And just take 7/16 14 tap. I like the OSG coated taps that I use. And I just put a little tap juice on them. A little rapid tap or Castrol Molly D works the best. That stuff's expensive too. And I tap them by power right here on the head. I'll run it in and we'll run it on down. And then when I get to the bottom of the thread for my stop, I'll just hit reverse and pull right out. Unfortunately, I already did them, so I can't show you that. But I just finished tapping them. But now I'm going to get ready and cut for the valve seal. And I'm going to cut the pockets for larger valve springs. So let me set that up and I'll show you that on this lonely Saturday afternoon in the shop. I know I haven't been making a bunch of videos here lately. It's just been, I don't want to say it's been quiet. It's been busy as hell, but it's been quiet as far as showing you guys any cool things. The funny car and the Hemi kind of held up at the moment. Money, extra money to throw to the race car just hasn't been there. Just paying the bills, getting work done. Our Hemi's still sitting, and I'll go over that a little later. I got a couple, my mind's going constantly. Last time we were just held up with getting the right set of connecting rods to make this short deck work. But I was trying to figure out a way to get around that. But no matter what I do, whether I start on a different block with a different deck height, everything needs something. As far as this block needs rods, that block needs sleeves. To use these rods I had to change the stroke on the crank. So no matter what way I slice it, there's about $1,000 to spend that I just haven't had in the last few weeks. So, but pity trip on me. World's smallest violin. I'm not going to play that. A little cool project here is a little Oldsmobile 455. I'm building for a little street strip 70 Cutlass. I'll go over that later. I finished the machine work and got the bottom end together. But I'll go over that a little later as we work on these heads. But let's get back on these 441s and I'll show you what I'm doing there. So we're going to set up the machine, the valve guide castings down for the valve seal we want to use. And with small block Chevy, you got to come up with a better idea for what you're going to use for seals, because the factory, that's one thing the Chevrolet engineers didn't do well on the small block Chevy was like the valve seal, the stem seal was an afterthought. So you got a lot of different choices when it comes to seals. The factory seal is nothing more than an O-ring that slides over the top of the valve stem. And when the heads were brand new and the guides were nice and tight, they probably worked well for about 10,000 miles. And then you would always see that telltale of that motor once it starts up and that puff of white smoke out the tailpipe. And then it went right away. That was always a telltale sign the valve seals were gone. So what we try to do is figure out what we want to use. I said you got your factory O-rings that come in your gasket sets. Some of the better gasket sets will come with these press-on rubber seals, and these you don't have to machine the top of the guide. They just press right over the top. Problem is, depending on your spring selection or what you're building, if you're building something with a little bit of a high lift cam or something with performance oriented, these big seals do seal well. They don't require any extra machine work, but they do not fit through the valve spring. So that's a no-go on anything but maybe a single spring or something of that nature. You have these little plastic, hard plastic, I call these more or less oil shields. On the ground. More or less an oil shield. And again, these are hard plastic. They could slip over the top of the valve and just sit there, kind of ride up and down and work like an umbrella. You know, if you're just redoing something in your backyard and just changing seals and don't plan on pulling the heads off and it's just a grocery getter, I mean, these are better than these O-rings. Honestly, if you don't have a choice, if it's something, like I said, you're not taking the heads off, I'll usually use these and put that factory O-ring on top of it just for some added benefit. But it's something I don't normally ever do, but unless I was stuck out on a deserted island and that's all I had, and I had replacement valve seals. That's about the only time I would use that. The tried and true, which was known as the Perfect Circle seal, which was the name of the company that developed these back in the early 60s. These are your press-on Teflon seals. These come in different sizes. You can get these with an ID of anywhere from 530, talking in decimals, 530, a little over a half inch, 500, a half inch, or even down in the 470, 450 range. So these here will machine down the boss, and then we'll take a little tool, a little billet aluminum tool there, and I'll show you these later when we assemble them. And the spring, the seal just slides up in there, and you just pop this on after you machine it, and just tap it down with your little brass hammer or rubber mallet. But to make these work, you have to machine the guide. And again, if you're running a high lift cam, you have to know your measurement from the bottom of the seal to the bottom of your retainer there when you're coming down, because see if I can pull this off. I should have got this ready beforehand. Let's visualize the valve is in there and the retainer sitting there. So you have to have adequate room when the valve spring closes or valve opens, the spring starts to close, that you don't run into the bottom of the retainer of the seal when the valve's opening. So you have to get that measurement right. I like to shoot for at least, I like to get 100 thousandths between the top of the seal and the bottom of the retainer. That's what I look for. Something crazy with a 1-inch lift, we might not be able to get that much, but we're not doing that here. This is just a street car with a hydraulic roller, around a 570, 580 lift cam. So I'm going to pick these seals. I'm going to use the Perfect Circle on this particular setup. Again, some of the other seals that I like to use, these steel-clad Viton seals with the little spring wire. These are nice. I like these seals. They work good. And these were factory on a lot of your foreign cars, your Hondas, your Japanese cars, import cars had a good valve seal, and they last easy 100,000 miles. But it's a good seal also, and you can get these. These actually take up a little less room than the Teflon seal. So if you're trying to fit them between a spring, they're always a good choice. But how these work here, we buy these tools. Again, this is just a little tool, and it has a pilot that centers itself in the valve guide, and all different sizes. Like for instance, this one here, if you look on the side, 500, which means this will cut the diameter a ½ inch. 500 thousandths, ½ inch. So I'll come down here with this and just go through this in the seat and guide machine. Now, years ago, I used to use a big electric drill and sit these on a steel stool and do them when I was a kid, but it's a little nicer to have them clamped in something rigid. And now I'll go down a little more because I know we're putting a good sized cam in here. You notice it's facing the top of the guide now. That's what we're looking for there. So now I'll stop it. I'm just going to hold that down and I'm going to set my spindle stop here. So I can just motor on down the line and do the rest of them. I've done them enough to know that for this little cam, that's going to be a good height. I can check it with a pair of calipers. I'll show you in a minute. But I probably took off about 150 thousandths off the top of that and to a shorter guide. You don't want to make the guide too short because, I mean, the guide is, what holds the valve stable in the head. So a good length of a guide, to keep that valve stable. You don't want to go too excessive. You want to get just what you need. So I believe that'll work well there. And let's cut down the rest of them. And this is what I was talking about here. Measuring from the top of your valve stem, top of your valve guide rather, to the bottom of the spring pad. Now we're going to cut these spring pads larger too, because small block Chevy, you can't put a very big valve spring in. A 1-inch 250 is the biggest diameter spring you can use. And again, like I said, this is getting a healthy healthy hydraulic roller, like a 580 lift. So we're going to put him some 1-inch 500 springs. But right now, checking to the top of that height, a little over 700 thou. We'll call it 710. And like I said, I just eyeballed this because I've done enough of them to know kind of where I want it on something mild like this. So we cut it down to 575. So 576, 75. So about 150 thou, just like what I was saying. And now I set my stop, and I'll just run down the line. And like I said, what we were trying to do, we're trying to not only turn this diameter down to make a nice precision diameter so the valve seal will press snugly over the top, but we're also bringing this down to gain some clearance to the retainer. And the Vortec heads are notorious. Vortec heads, the guides are a little higher, and you're really lucky in a Vortec head if you could get about a 460 lift cam before when the valve starts to open, the top of the retainer will collide with the guide. So remember, on your Vortec head, if you're doing a weekend cam swap and you're not pulling the heads and you're pulling out that factory cam that has about 390 thousandths worth of lift, and you're popping in a hot little comp cam's 292H with a 500 lift, you're going to have problems. So if you're not going to machine the head, don't go over 450 lift on a Vortec head. An old Chevy head, like these old 441s, they'll hold pretty close to a 500 lift without cutting the guide down. Really close. You can get away. As a kid, I put plenty of 280, 480s and stock Chevrolets with stock heads and never had a problem. But anything over that, you're gonna want to check it and get it machined properly. So we'll cut these down now. And again, this machine, and you could do this. You could buy these cutters. They sell them. Summit. You could buy these. You see, I got a bunch of cutters and different things from over the years. You could buy these cutters from Summit. They're like $100, and you could put it on a big 1/2-inch drill motor, and do it by hand. It's just a little easier on the old machine here. It has a foot pedal, a little air float table. And like I said, it's Saturday evening, so instead of sitting in the house and watching Flow Racing and other people race, I might as well listen to it on the TV while I'm fooling around and go ahead and knock these heads out for for my buddy Mike. I can't seem to get it in there. Yeah, trying to hold the phone and do this at the same time sucks, right? One of these days we'll do something better with the phone holding apparatus. But you know, if I'm not struggling, I'm not really happy. That's making me look stupid here. I can't. There we go. Float it in. Spin the line. And I won't film every one of them. I'll just show you this one, and then I'll put the phone down and finish them up. And then I'll switch the tool over, and we'll measure the spring, figure out what kind of spring we want to put on here, and we'll machine these spring pockets a little bigger. But you notice, I mean, it takes a little bit of time to do this. So when people say, "Oh my God, my bill at the machine shop was so high," well, I mean, time is time. I mean, whether you're paying a plumber to fix your commode or an electrician, I mean, everything's time oriented. That one's done. So, and you know, typically, we can knock this whole head out in about 10 minutes. So I'm gonna put the phone down, and we're gonna finish machining all these. All right, cut all them, and customer got lucky. The guides on these heads are in really good shape as far as clearance. I mean, they're real nice. These must have been a pretty low mileage set of heads, or well taken care of oil changes. They're not worn out, so that'll help him save a little bit of money, because again, every operation, it adds up. You know, if I would have had to, like a lot of these heads where the guides are just shot, if I had to put a full set of guides in them, you know, it would have been another couple $100 added to the bill. And you know, before long, when you give these guys their invoice and they have a heart attack and say they could have bought some Chineesium Pro Comps for $450, yeah, I get it, I understand. But again, time is time. Equipment and tooling costs money. We're not getting rich here, fellas, so trust me. But we're gonna pop the other head up here, and I'll machine the other tops of the guides for the seals, and then we'll set up and we'll machine for our springs. And I'm gonna go through these heads, like I said, from beginning to end, to show you, you know, what it takes and what it costs to refurbish a set of old, like I said, these are old 441s, nothing special. Probably the better of any of the open chamber designed heads. They were heavier metal, thicker casting, so the 441 to 993 was about the best open chamber head, which normally I wouldn't hit a hog in the ass for an open chamber Chevy head, but I've had them on the flow bench, and runner wise CFM up to 550 lift, they flow just as well as any double hump, or whatever you want to call them, double hump, vet head, 300 heads. They just have a little less efficient combustion chamber, being it's an open chamber, and it brings the compression ratio down. So that's why these heads have a bad rap of not being a performance head, because it kills compression. But again, this is going in a 380-inch plus motor, and has to be street friendly. So it's about the only other choice without buying an aftermarket head. And again, he wants cast iron heads. He wants a nostalgia look. He wants to use perimeter bolt valve covers, and this is what you get fixing up old heads. So let's swap this head out and do another one. So we got our spring cutter set up. I just cut the first pocket. You gotta be real careful on stock small block iron heads not to cut the pad any deeper than where the factory cut it, because it's really thin under there. And a lot of guys will put a valve spring shim to hold the bottom of the cutter from cutting deeper. You know, I could feel it and get an idea where it's at. I don't think that's necessary. Now, if it was an old set of marine heads, I've had marine heads actually, when you cut the diameter bigger, show signs where they're rotted through, because all the water jackets run right under here, under the valve spring pad. So that is pretty thin. So you got to be careful. You don't ever want to deepen the pocket. So as you can see, I'm just barely blending it in to where the factory witness mark is. And you can get it close. I mean, you can't even feel a transition line. It's right to it. So I'll show you how this works. And again, seat and guide machine, air float table with a pedal. Guide pilot lines it up. Maybe put a little drop of oil in the guide there because don't want it rubbing too bad. You go easy in the beginning because it is an interrupted cut. And we picked a 1-inch 500 spring we're running on this combination. Again, hydraulic roller, about 575, 580 lift. And I'm not setting the depth on the quill. I'm just going to blend it in by eye as soon as I get to the bottom of the pad, and you can feel it when it gets ready to take that full diameter cut. These take a little longer to cut than the seals, just because we're removing more material. And you can see how we blended it in right there. So now we'll just go down the line and our spring puts right in there now, nice and snug. I always like to cut, and I have different sizes of all these cutters also for the valve springs because I like to cut it just right to wherever if my spring's 1.5 inches, I use an 1.5 inch cutter. The cutter's got about 5 thousandths worth of side clearance. If it's a 1.550 spring, I use a 1.550 cutter. I try not to deviate. I don't like to use a 1.600 cutter and put a 1.400 spring. I don't, it is nice to have the casting help hold the spring in there from walking around. So that's what we're doing there. I'll go down the line and we'll cut all these. And then after that, we'll blow them off, and we're going to take them over to our old school Van Norman rotary broach. It's an old iron head. I like to use my old iron machine to machine it on, to mill it on. Again, we have several machines here in your favorite backyard machine shop. We got the CBN there on that side that we do aluminum LS stuff on. We've got a block master that I dedicate just for cutting blocks on. But normally, we use the RG 900 here to do our cylinder head milling, but on iron small block heads, the rotary broach still does fine. We're using old school composition gaskets, so we don't need that mirror finish like we do on an MLS style head, or like here's a Honda head I'm getting ready to do. This was cut on the CBN. You can see the nice finish that you have to have for MLS gaskets and elite model stuff. But let me go ahead and finish cutting these springs, and we'll get on to the next operation. All right, we're all machined there. So let's swap heads and put the other one on and do our valve pockets on the second head here. And then we're going to do a little segment of surfacing them, old school. And I'll probably upload the video at that point, make this a 2-part video. And then after we do that, we'll do our valve job. Again, old iron small block heads, factory 194, 150 valves. We're going to put 202, 160 intakes. And we're not going to do any porting and polishing, but we are going to go down with a bowl cutter in the throat just to do a quick removal of some of the main material that impedes flow. Again, this is for a street car that's going to be a little 500 horse streeter, old school iron heads. And that's the name of the game. That's what we do around here. Anything old and slow to machine, that's my specialty. But we jump on this other head and we'll get them machined up and surfaced for the evening. I'll tell you, as a kid when I was doing this, again, like I was saying, I would do this by hand with the cutter and a drill motor. And back then, in the 80s, I had this drill motor my dad gave me, and I think it was his dad's. It was a Craftsman drill. It weighed about, it felt like 100 pounds back then for my 15-year-old hands. It made a man out of you, because when you machined it by hand and that big old Craftsman drill would grab or catch, you better be hanging on to that thing. You'd be going around the stool that I was working on with the drill. That thing had so much torque. They don't make tools like that. I wish I had one to show you, but it was pretty funny. I did it like that for years, and not only was it dangerous, played hell on the carbide, brazed carbide tool bits when they would grab and break and crack. But wish I had a video of that. It'd be pretty funny, seeing a 15-year-old kid spinning around with the drill. That's why I'm gun shy today, I guess. Let's keep rolling here. This is my trusty old Van Norman rotary broach that was probably, standard in the day, 1950s and 60s. But it still works really good on surfacing cast iron heads, and setup's really quick. Process is fast. Not the most super precision, but on the regular serviceable stuff, street cars, grocery getters, works good. And I've checked it. I can hold a couple thou on this, no problem. Head lays down on this plate and surface, and depending on who's using it, I keep a stone here near the machine, and I always circular motion and go over the clamping surface every time I get ready to use it, just to knock down any high spots in case somebody bounced the head around, nick the surface, scratch the surface. Try to keep, even though it's old equipment, try to keep everything as good shape as possible. I just take this honing stone, like I said, in a circular motion, and I just periodically just hit it, just like I said, just to knock down any high spots. All right, I'm going to show you how I set this sucker up. The old Van Norman rotary broach. All right, so these are the 441s we were just cutting the seals and the springs on. And this head sits down right above the cutter on this plate where I was just showing you, where I was just hitting it with my stone here. So it's imperative on these heads that they're fairly clean and devoid of any deep scratches or anything that would raise the head up, because you want this head to sit as flat as possible. So now, using the CBN over there, or the Blockmaster, where the head mounts right side up and the cutter goes over the top, you really don't have to worry about the head being, super clean or having any serious imperfections. So what I do, and I know I'm going to hear the shit about this, I know everyone's seen the video on not to use these to clean gasket surfaces, and everyone has a video of somebody that got aggressive and cleaned gaskets off and warped the fucking head. And you know what? I've been using these things forever. There's nothing wrong with using these to clean surfaces as long as you're not a total retard. I mean, you feel what you're doing. You're not gouging in. Very lightly, you're taking off the gasket material. And you're surfacing the damn head anyway. So, like I said, I'm sure I'm going to hear about this, but I use these my Milwaukee, this is a cordless one. I used to use the little air ones, Whiz Wheel or whatever you call them, with just got the little roll-lock Scotch-Brite pads. And that's what I use to clean gasket surfaces. And like I said, as long as you're not a total idiot using it, you'll be fine. So let's go ahead and fixture this head up. Now, again, these is an old set of heads, and if it was a max effort deal, we would really pay close attention to getting both heads exactly the same. So what I do on a head, we don't know if these heads, it's 50, 60-year-old head, could have one head came off before, somebody replaced the head gasket, one head's been maybe milled, maybe the other head hasn't. Well, what I do on something like this that's not max effort, all-out race deal, I measure with my calipers the bottom of the deck from the intake bolt hole on both sides, and I get an idea if one head is deviated much from the other head. And what I'm trying to do now, again, we're not trying to make compression, we just want a nice, clean, straight gasket sealing surface. But I do want both heads as close to the same as possible. Again, if it was a race car, we would be CC in chambers. There's a lot of different methods we would be doing to get both heads exactly the same. But a quick method, you could check from the bottom of the deck to the bolt holes, because when these were machined at GM, everything was fixtured off a datum point, and the intake center line had to be a fixed number from the deck of the head to get the valve train geometry and everything the same from head to head for millions of heads that they manufacture. So I just go by that, and I usually find that a pretty quick method way of checking head to head. So we've already checked that, and they're within a couple thou. So we're going to fixture this head up, and we're going to take off the minimum, but it'll probably still take 10 thousandths to clean it up. So let's fixture it up, and I'll show you how I mill these on the old Van Norman rotary broach, circa 1955. So another tool I come up with is my little paper shims here. These are just little squares of copy paper that I just cut in little 2x2 squares. And what I do is, the way this machine works, the head just lays down on that table like I was telling you. And you can either use these jaw claws that'll clamp and tighten the head, or these plates, which I actually made these plates a while back, and I put some chains on them so I could pick them up with the engine hoist, because they're so damn heavy when I have to use the claws. They get in the way sometimes. But what these plates do, if you want to deck a block or heads, they sandwich the heads. And I just tighten them together with threaded rod. And I'll show you that in a second. But the whole idea of the paper is twofold, no pun intended. The paper not only shims the head up above the table, so we're not dragging the steel table across the steel head. Because, again, this is cutting cast iron, it's making little granular chips, and it's very easy for a chip to get up between the head and the machine and just drag it along and put deep scratches in it. And a lot of times you'll find these machines used where nobody's ever did the paper trick, and the tables are just really rough shape. So the paper generally is 5 thousandths thick, so it's sitting up just a hair above the table. And both also, as I sit it on all four corners with this paper, I can feel the drag. Now, if there's no drag on the paper, it tells me that the head's fairly straight at least within 5 thousandths. Now, a lot of time when the head is super warped, you'll feel there'll be nothing you can do. You'll feel the paper will slide right out. It might be tight there. So what I'll do then, I'll do a three-legged dog. I'll put a piece of paper in the center and just two on the outside and get the head straight. But years ago, I decked a block for a super stock racer that came down. He was a little disappointed that he didn't know what kind of equipment I had, and he saw this rotary broach. He's like, man, I don't know. I need this block right. This is, a record-holding super stocker, and I'm building a new motor. It was actually a 396 big block, and he wanted to hang around while I did it. He gave me a shot to zero deck his block, and he brought his own tools, and he was surprised that I got the head on all four corners within a half a thou. So I think the machine probably wasn't designed to hold tolerance that close, but playing with it, you can get there, and it'll suffice for this kind of work. So, like I said, we're on the paper, shims it up, it's got a little bit of drag. Now I'm gonna go ahead and tighten up the plates and touch off. So give me a second and let me tighten up my fixture plates, and we'll take it from there. All right, so we're all clamped down, plate sandwiched the head, and I tighten them up in a crisscross pattern just to try to bring the head down equal. And then I check my drag on my paper, make sure it didn't lift up when I clamped it down. Sometimes if you clamp it down and tighten one side up too much, you'll cock the head or jack it to the side. So it's important you check these papers. As long as you got drag on both sides, you're telling me you're pulling the head down equally. So what I'm gonna do now is fire the spindle up. And I got a little yellow line you could barely see here that I calibrated this to 0. Because remember, and how I calibrated this, it's supposed to be 0 to when that cutter is exactly the height of the table. So as you wheel this up and down, the cutter raises and lowers below the table, get the head clamped down, and then above the table, the machine. So being the paper's 5/1000ths, we're gonna touch the head off, just touch the head off, and then we're gonna dial it in at 5/1000ths and see what we have. So right now and I always back up and come to my number just to take the backlash out. I never go back and forth without going beyond my number and then cranking to it. Like you would run a Bridgeport, without a DRO. You gotta take your backlash out. So I always lower the spindle 1 revolution just to make sure when I'm clamping the head I'm not gonna hit the carbide cutters. So right there, 0. So as I get to 5, you should just start here, this thing barely hitting the head. Hear it? And that's right at 5/1000ths. And so right now, basically, we're above 5/1000ths. Remember, our paper's 5/1000ths. So that right there is where we're gonna make our first pass. So I'm gonna back this off, back below 0. I'm gonna traverse the head back. You notice the whole head's traveling now on the ways of the machine. I'm just going to back it off enough to get the cutter off the head. There we go. Now, like I said, I backed it up beyond my number. Now I'm going to come back to my number, taking my backlash out. 5/1000ths for my paper. And right now I'm just going to take off 1 more. So that's 6 on the gauge. But theoretically, we're only going to be trimming off 1/1000th off the head right now. So we're going to take 1 off and we're going to see what the head looks like. Now we put it in, turn the feed on, and it's a fixed feed and speed, folks, so there's nothing here to adjust. Very simplistic, very fast. Hear it? Starting to cut. And they did it this way forever. And like I said, a lot of guys laugh at these old machines, but these old machines were built to machine old heads. When this machine was new, these heads were new. So they work kind of in unison. And if you're using old gasket technology, Velcro and Mr. Gasket, composition gaskets, there's nothing wrong with a rotary broach surface. Again, I wouldn't do it with MLS gaskets or on aluminum heads. You've got other machines for that. But for this, it's fairly quick, fairly easy. The setup doesn't take a skilled operator. And you can find these machines. Man, you could get on Marketplace. I mean, a garage shop, most of these machines are single phase 220. I've seen these machines sell for $300-400. This is a larger one. This is a number 570. In my garage at my home shop years ago when I was doing this just for my own racing purposes, I had what was called a Van Norman 530 mini broach. And it's about a little less than half the size of this. And it's great to have in a little garage, and it's just big enough to do big block Chevy heads and blocks on. It'll take a few minutes to cut, so I'm going to let this cut through, and then we'll look at the surface of the head and back it up and make another pass. I shouldn't have put the phone down. If you hear now, it's no longer cutting. It's just cutting air. So characteristically, you heard it cut when the cutter started on this end. You watch. It's going to miss the center, and then it'll start cutting when it gets past this exhaust port again, which characteristically, she's warped. So, you see now it's starting to pick up little machining noise again, it's starting to cut. Small block heads are notorious for getting the hottest right here at the Siamese exhaust ports. One of the reasons small block Chevy never did great as a blown nitro motor is you can never get these cylinders to the same exhaust temperatures as the outboard cylinders. These two ports so close together. You always got to put more fuel to them to cool the hole. And I'm talking mechanical injection on like a blown alcohol or blown nitro deal. And I'm not saying they didn't make good power. I mean, you know, back in the 60s and 70s, and there's some badass blown alcohol and blown nitro small blocks, and there still is. But going up against a Hemi or a spread exhaust port style motor, you just can't do it. Again, it's just visually explanatory. Those two ports together run so much hotter than the outboard ports. But here, how much heavier it's cutting on the ends. That's probably got a good holiday in there where it missed the portion of the center. And remember, we're only taking off one thou. So what we'll do as soon as we finish cutting here, we're going to back it up, and then we're going to dial 5 into it, and that'll be a true. That'll be 7 thousandths total, and if it cleans up, we know we'll do the next head 7 thousandths. The other head doesn't clean up to 7, we got to go more, then we'll have to pop this head back on and match it up. So you'll hear it finish the cut here in a minute. The cutter's sitting at a slight angle, so it won't back cut. The only time it'll back cut is if you have something clamped incorrectly. And you can see all the paper on the floor where it falls. Got a little tray on there to catch the chips to make it easier to clean up. Alright. There she goes. She finished the pass. So now I'm going to put it in neutral, and I'm going to rapid Travis it back. And you notice the cutter isn't even dragging. There's a 1/1000th cut. I mean, you know, I've seen some new machines that can't take off 1/1000ths and travel back without you hearing the cutter back cut. So I'll back it up a little bit, and then what we'll do is, this machine's pretty cool. It has a fluorescent light underneath it. And that was factory. And why does it have that light? Well, take my little mirror here, and we'll look down and see what we got. You can see where it touched off there, touched off to the end. See where it missed the center there? I don't know if you can see really well. That 1/1000 did not clean it up, which I didn't think it would. But, you know, we're pretty close. The head laid nice and flat. Missed the center, caught the 4 edges. Now let's go ahead and dial this sucker in. 5 thou. Turn the power key on. And this should be our last and final cut on this head. Can't see, but the head is being suspended just a hair over this steel table. Obviously, the more you cut, The higher the cutter's raising and the bigger air gap you're going to get, but it's being suspended by these big plates that are held together, threaded rod, and the clamping method from my Bridgeport. All right, getting right here to our end of our cut. Remember, we dialed in. The dial says 11 thou. Remember, our paper was 5/1000 thick. That's essentially just a 7/1000 cut. Or 6/1000 cut, rather. That's 6/1000. So again, if you're careful cleaning gaskets with these, there's nothing wrong with it. As long as, you know, you don't go crazy Hulkamaniac with it. I mean, you see the head just about cleaned up with 1 thou. So I know I'll get backlash for that, but what the hell ever. So I'm going to back this up now and take a look. And I'm pretty positive it cut 100%, because it sounded like a nice cut the whole way. So, but I'll double check it with the mirror on the stick there. So give me a second here to back it up. So there you go. Your 6/1000 cut on your old 441 small block Chevy head. I think it does a pretty good finish for a 70-year-old machine, and pretty precise. Again, that was only 6/1000, and we'll match the other head up here in a minute that we were working on. So I'll probably go ahead and upload this video. It's getting a little long, and then I'll continue on part 2 with our valve job. We're gonna do 202 160s. We're gonna do some bowl work with a bowl hog. We're not gonna do any porting and polishing. Again, this is a little street car, and I'm gonna call it good at 6/1000 cleaned up, because we don't want to make a lot of compression. Again, that's why we chose these open chamber heads. It's a little street driver. It's an iron head, so it can't use as much timing as an aluminum headed motor. Again, the aluminum head dissipates a lot more heat, so we can get away with about a point higher compression. So steel headed motor on the street, 10 to 1 is about your limit. So, and that's how we do it here at Prince Brothers Backyard Machine Shop, RPM Speed of Machine. Apologize for little lapse in being with you guys. Just been busy in the shop, and you know, I don't want to put a lot of rhetorical repeat information on. Haven't had much progress with the funny car. A little slow down issue happened with that. I'll go over that on another segment. I did get the second motor done for the boat. Obviously, we didn't make 4th of July, but at least I'm getting projects that I started finished. Number 2 motor, I think I'm going to drop in tomorrow if it's nice out. If it's not too hot. It's been so damn hot down here, 110 degrees every day. It's like, fuck it, I ain't going out there and working on that thing in the dead of the heat. Wait till the evenings, putz with it. But just trying to finish these heads up for a customer. Except we're going to finish the valve job up tomorrow, and we'll assemble them and set the spring height. We'll show you that. And I'm just going to do a list of what we did and document the prices we charge to do something like this, just to show what it takes to rehab an old 50-year-old set of heads. And you know, I don't think our prices, we're not the cheapest, but we're definitely not the highest. But just to give you guys a relative number of you know, what it takes to go through something like this without buying new. So, all right, guys, have a good rest of your evening. I'll catch up with you in part 2 of the 441 small block head rehab for the 29 Model A that they're going in. Later, dudes.